you switch on your computer or mobile phone and start using apps, surf internet or send emails, bytes of information start running through different data networks, making their job so that you get what you want. Almost everybody in the modern countries have a smartphone or a computer. Around 5 billion people use internet worldwide. Since year 2000 to 2020, internet usage increased by astonishing 1,266%. It is estimated that about 306 billion emails are sent per day. Taking into consideration that we are 7 billion people now, it makes 43 emails per person per day, including babies, kids, elderly people and people that never use the computer at all. It generates a huge amount of data and traffic. For example, every minute, Americans generate about 3 million gigabytes of data traffic. Annual worldwide data use is estimated to 241 billion gigabytes. This amount is so huge that it's really difficult to imagine it. If we convert this amount of information to old-fashioned paper books, the amount of information we produce per year would fit on 128 trillion double-sided pages. If we pile them on top of each other, it would make a stack approximately 12 million kilometers high. This is more than 30 times longer than the distance between the Earth and the Moon. Generation of such huge amount of data requires corresponding amount of energy. Different scientists try to calculate amount of energy required to generate 1 gigabyte of data. Depending on methodology that used to calculate energy flows, generation and transport of 1 gigabyte of data requires about 5 kilowatt hours of energy. End user pays only 38% of the electricity costs. Rest is spread over the global internet through which the data travels in switches, routers, signal repeaters, servers and data centers. Globally, data transmission networks consume about 260 to 340 million kilowatt hours in 2020, or about 1.5% of global electricity use. Some companies consume huge amount of energy for the internet services they provide to the end users. For example, Google company alone uses about 12 million kilowatt hours of energy per year, which is more than the entire energy consumption of such country as Uruguay or Lithuania or Bosnia and Herzegovina. Another example is Facebook, which consumes about 7 million kilowatt hours of energy per year, which equals annual energy consumption by entire countries such as North Macedonia or Latvia or Honduras. If we put together Google, Apple and Facebook, their joint energy consumption would equal 21 million kilowatt hours per year. That equals to annual energy consumption in Cyprus, Luxembourg, Latvia, Estonia and Fiji altogether, with total population of 6 million people. Another huge consumer of energy in the digital world is cryptocurrency. Bitcoin mining is an energy-intensive process. It is estimated that at the present level, Bitcoin consumes about 81 million kilowatt hours of electrical energy annually. If Bitcoin were a country, it would rank as number 39, right below Belgium, but ahead of such countries as Israel, Switzerland or Greece. Interesting fact, since Bitcoin is so energy intense, each Bitcoin transaction consumes about 1,100 kilowatt hours of electricity. For comparison, this amount of energy is used by an average household in Europe or USA during 55 to 60 days. So every time you buy something, even a cup of coffee, and pay it with Bitcoin, your transaction would cost about 200 euros, depending on electricity prices in given country in energy costs. On an average day, about 240,000 Bitcoin transactions are sent over the network. Enormous energy consumption by Bitcoin generates also huge carbon footprint comparable to that of New Zealand, producing about 37 million tons of CO2 annually. Global carbon emissions of internet and data traffic constitute around 45% of total greenhouse emissions. It is estimated that the internet will use a fifth of all energy world electricity by 2025. It raises a lot of questions about energy use and carbon footprint. Many companies, both end users and service providers, go over to cloud, both cloud computing and storage. In fact, cloud computing is more energy efficient. However, it completely ignores the network transport energy and the additional power consumed by the end user devices when accessing the cloud. Volume of traffic generated by a session of application typically exceeds the amount of data input by the user by more than a factor of 1000. With transition to new green renewable energy sources, this should not make any problems. However, according to International Energy Agency, global electricity demand is growing faster than renewables, driving strong increase in generation from fossil fuels. Global electricity demand is growing about 5% per year. However, share of renewable energy sources grows slower, and it is estimated that renewables will only be able to meet around half of the projected increase in global electricity demand. Fossil fuel-based electricity generation is set to cover about 40% of additional demand, which will lead to 2 to 3% of carbon emissions into the atmosphere. I hope you have learned something new today. Please feel free to contact me with the suggestions for other interesting topics, and I will do video about it.